Hello students, now in NEET 2017 I have the next 5 questions from 31 to 35. So now question number 31. In a electromagnetic wave, in free space the root mean square value to electric fields is ERMS equal to 6 volt per meter. The peak value of magnetic field is, now the options. First option is 1.41 into 10 raised to power minus 8 Tesla. Second is 2.83 into 10 raised to the power minus 8 Tesla. Now third is 0.70 into 10 raised to the power minus 8 Tesla. And now fourth is 4.23 into 10 raised to the power minus 8 Tesla. This is not so much. So now we are given the RMS value of the electric field in the electromagnetic wave, which is propagating in the free space. And we are to asked to find the value of the magnetic field, the peak value of the magnetic field. So now we know that this E naught upon B naught is equal to C. This is known to us, this is the formula. The ratio of the electric field to the magnetic field is equal to the speed of the light. So this E naught, this ERMS is given here. So this E naught equal to root 2 into ERMS. So this is now your root 2 into 6. This is given to us. Then we have to find this B naught. B naught is to be calculated. So now put the value. This is now your root 2 into 6 upon B naught equal to 3 into 10 raised to the power 8. So this will give you what? The B naught equal to. Now 3 to 6, this is now your 2. This is now your 2 root 2. 2 root 2 into 10 raised to the power minus 8. 2 into 1.414. 10 raised to the power minus 8. So this will be your 28 after 3, this is not so much, 10 raised to the power minus 8 Tesla. So this is now second option. If we leave to this 8, then this will be 3, so this is now 2.83 into 10 raised to the power minus 8 Tesla. So our answer is to what? Second answer. This is not correct answer. So this is the direct use of the electric field to the magnetic field and the speed of light. Now question number 32. 32. The bulk modulus of spherical object. Bulk modulus of spherical object is B. If it is subjected to uniform pressure B, P, then the fractional decrease in radius is now the options. Now first option is this is now P upon B. Second is B upon 3P. B upon 3P. And third is 3P upon B. And fourth is P upon 3B. This is now options. You are given the bulk modulus. This is the question from elasticity. So the bulk modulus B is equal to P upon delta B upon B. This is the formula. So delta B upon B. Delta B upon B is equal to P upon B. This is the change in volume to the initial volume. Then this is so much, but we have to find the radius. Decrease in radius. Volume. B equal to 4 by 3 pi r q. This is a spherical object. So this is delta B. This is now your 4 by 3 pi r cube. This is now your 2 r square. Then this delta r. Just to differentiate to this one with respect to r. Then you will find this relation. So now you put these values. Therefore, this 4 by 3 pi into 2r square. No. This is not 2, no, this is not 3. 3r square into delta r upon. Then this is now your 4 by 3 pi r cube. 4 by 3 will cancel. R cube, this is now your 1 and this will cancel. So this is equal to P upon B. Now delta R upon R. Delta R upon R. Here is 3. Multiply to this one. This is now P upon 3. So now answer is P upon 3B. It's now fourth one. Answer is fourth. So what you have to find? First we apply the formula, then have the volume of the spherical object and then change in volume. This is now 3r square into delta r. Now put these values here. Then you will find that these values will cancel. Delta r upon r is 3 multiplied to this one. So this is now so much. So now correct option is fourth. 32. Now question number 33. 33. The ratio of resolving power. Ratio of resolving power of an optical microscope optical microscope for two wavelengths lambda 1 equal to 4000 angstrom and lambda 2 equal to 6000 angstrom is. Now your options. First option is 8:27. Second, 9:4. Now third option is 3:2. And fourth option, this is now your 16/81. This is given to us. So now solution to this question. We know that this resolving power is proportional to 1 upon lambda. This depends upon the wavelength, but this is the reciprocal of lambda is equal to the resolving power. So Rp1 upon Rp2. This will be your lambda 2 upon lambda 1. And from here, this is now your 6000 angstrom. This is upon 4000 angstrom. These will cancel. This is now 2. This is now your 3. So what we have? 3 upon 2. So we are having the ratio 3:2. So 3:2 is now option third. So our answer is third. So this is how to apply the formula. Nothing more to think about it. You should know the relation between the resolving power and the wavelength of the light used. So by having this one, you can find the direct answer. Now question number 34. Consider a raindrop. Consider a drop of. Consider a drop of rainwater having mass 1 gram. Mass 1 gram falling from a height of 1 kilometer. It hits the ground. with a speed of 50 meter per second. Take G constant. Take G constant with a value your 10 meter per second square. The work done by first gravitational force and second resistive force of air. Resistive force of air. Now the options are given here. Now your first option is in the first this is equal to minus 10 joule. Second is minus 8.25 joule. And now option number 2. Now first is 0.25 joule and second is 8 minus 8.25 joule. And now third option is first is your 100 joule and second is 8.75 joule. And now fourth option, first is 10 joule and second is minus 8.75 joule. This is the question. Solution. We are having a raindrop. This is falling from here. This is now raindrop. This height is 1 kilometer from this to this one, ground to this. And this when this strikes here, then we are having the speed is 50 meter per second. So from here it falls freely. Falls freely, the initial speed is 0. So here we are given that the mass m equal to 1 gram equal to 10 raised to the power minus 3 kilogram and the height h equal to 1 kilometer equal to 1000 meter and the value of g, this is your 10 meter per second square. Now initial velocity, Vi is equal to 0 and Vf is equal to 50 meter per second. This is given to us. So work done by the gravitational force, first gravitational force, work done by gravitational force Wg, this is equal to mgs, the gravitational potential energy. So this you apply the formula, put all these values. M is 10 raised to the power minus 3, G is equal to 10, this is now your 1000, this will cancel by this one, so this will be your 10 joule. It means that Wg is equal to 10 joule. And now work done by resistive force of air, that means WA. This is to be found out. We are given the work done and the kinetic energy, because the velocities are given here. So we apply the work energy theorem. Work energy, delta W is equal to delta K. So this is now your Wg plus Wa equal to half m Vf square minus half m Vi square. Total work done is so much. Wg is equal to 10. Wa you have to find. This is now half m. M is given to be 10 raised to the power minus 3. This is now your 50. This is minus 1 by 2 m. This is now your 0. So therefore Wa equal to 1 by 2 into 10 raised to the power minus 3 into 2500 minus 10. This is not 2500. Minus 10 is on this side. So you can have that this now 1250. So now then what we are having, that this is your 1.250 minus 10. Then this is nice, so it's minus 8.75 joule. So much work will be done by the resistive force of the air. So now best answer, W the first is must be 10 joule. This is now your 10 joule, and second must be 8.75. This is now 8.75 with a negative sign. Negative sign indicates that the resistance of the air work against the speed of the object. So our right option is your fourth. The first in the gravitational, this is given the 10, then resistive force, this is now 8.75. So this is now right answer. So first you find the gravitational force, and in applying to this work energy theorem, always remember that here we take the total work done. There is no meaning of positive and negative. If suppose in question this is given to be not negative, then you take it to be negative. Otherwise, you take the sum of the two work done. Here this is a change in kinetic energy. The theorem states that the work done is equal to the change in kinetic energy. Change in kinetic energy means the final kinetic energy minus initial kinetic energy. Then you calculate and find the answer of the question. So this gives you the 34th question. And now question number 35. Question number 35. A spherical black body with a radius with a radius 12 centimeter radiates 450 watts. Power at 500 Kelvin. If radius were halved, and temperature is doubled, the power radiated in watts. The power radiated in watt would be, now we have the option. First option is 225, second is 450, third is 1000, and fourth is 1800. This is the question. You are given a black body. Now to find its solution, we are given the temperature and the radius of this body, and this is radiating the energy, so we apply the Stephen's law. E proportional T to the power 4. So this E equal to sigma T to the power 4 A into T. A the area, A spherical object, so 4 pi r square. T the time, so power is how much? Power P equal to E upon T. So this is now sigma T to the power 4 into 4 pi r square. This is now P. Now then P2 upon P1 is equal to, all these quantities will cancel, so this is now your T2 raised to power 4 into R2 square upon T1 raised to power 4 into R1 square. This will be so much. Now in the question this is given that this R2 is equal to R1 upon 2, halved. Halved means adha, 1 by 2, and this T2 is equal to doubled. This is now 2T1. For these values, T2 is equal to 2T1 raised to power 4. This is our R by 2 whole square upon T1 4 into R1 square. So this T1 4 will cancel. So this is now 2 raised to power 4. So 2 raised to power 4 means this is now your 18. No, this is now your 16 into this is now your 1 by 4. This will cancel by 4. So what we have? We have to find the P2 is equal to P1 into 4. So here this P2 equal to P1 given 450 into 4. So this is your 800. So much watt. So this is a direct application of the Stephen's law. But here we have to remember the radius is hard. So these data are not being used. If you use them, you will find the same thing, that this 12 centimeter will be 6 centimeter. This 500K will be 1000K. So then even by using to this data, you can find the similar answer. So this is direct use of the Stephen's law. So our right choice is to this question is fourth. So this is answer is now fourth. So this is how to apply the Stephen's law. So these are the 5 numerical questions from 31 to 35 of NEET 2017. Thank you.